concept of muscle contraction. Muscle contraction, you have this huge muscle fiber, which inside contains these little myofibrils, which in turn contains even smaller portions called myofilaments. Now, when you observe these filaments from cross section, we'll actually see that it has this surrounding plasma membrane, which is actually isn't called the plasma membrane, but rather this sarcolemma. Sarcolemma is a big word. It relates to flesh. I mean, it means of flesh, and it usually relates to anything involving the muscle. And inside of here, in between all of our little filaments, we have many mitochondria, which are necessary for ATP, which we explain later. And then going around all of this, we have the sarcoplasmic reticulum, which is the equivalent of endoplasmic reticulum, but regarding to muscles. And then cutting through all of this, we have these devices called transverse tubules. Transverse tubules are going to be important for action potential. Now, how does the contraction actually begin? Well, what happens is at the neuromuscular junction, we have this little action potential transmitted through and into the transverse tubules, and this reaches the sarcoplasmic reticulum. So this is going to transfer action potential to the sarcoplasmic reticulum, and what the sarcoplasmic reticulum is going to do is going to start releasing calcium 2+ ions. Now, before I start getting into what actually occurs here, I'll explain more about the structure of the sarcomere. Now, in the sarcomere, we have two major components. We have the actin, which are these little thin filaments, which generally surround the myosin, which are very thick filaments found in between. We have these little globular heads, which are actually going to bind to myosin and contract inwards towards the M line. That's how contraction occurs. Now, how does contraction occur structurally? Well, it begins by having the calcium 2 ions that we were explaining earlier bind to little sites in the actin called troponin. Now, what happens is when calcium 2 binds to the troponin, it causes conformational changes, which in turn expose